Hello, my lovelies. It's Susanna, and today I want to show you how to simplify this expression. We have the fourth root of, and inside we have the cube root of 40 plus the cube root of 135. Maybe let's start inside here. So we have the fourth root outside, and what can we do in here? We have a cube root here and another one here, so are we allowed to just add them? Unfortunately not, because these numbers in here are different. So then let's focus on this first cube root here. So we have the cube root of, and let's see which numbers we can find in the 40. So the 40 can be written as 2 times 20, for example. And which numbers are in the 20 then? So we have 2 times already. And for the 20, we can write it as 2 times 10. Okay, so we have 2 times 2 times. And what can we do with the 10? We can write it as 2 times 5. So we have 2 times 2 times 2 times 3 times, which means we can write this here as a 2 to the power of 3 and then multiplied by 5. And this to the power of 3 is great here because here we have the cube root. But we will see later how to work with this. For now, we're just happy that we can write the 40 here as 2 to the power of 3 times 5. Then we have this plus symbol here, and now we do the same thing with this cube root. Which numbers are in the 135? Because we have a 5 here at the end, we can write this number as 5 times 27 is 135. And now we have 5 times. And which numbers do we have in the 27? We can write this as 3 times 9. So we have 5, we have the 3, and then we can write the 9 as 3 times 3. And look what we have here. 3 times a 3, which means again that we can write this as a power as 3 to the power of 3. So instead of the 135, we write a 5 times 3 to the power of 3, where we have this to the power of 3 here again, and which is good for the cube root. But what can we do now? Let's still keep the fourth root outside. And what can we do here with our first cube root? We have a multiplication here now, which means that we can write this one cube root as 2 separate cube roots, which are going to be multiplied by one another. And in the first cube root, we have 2 to the power of 3. And in the second, we have the 5. Then we have the plus symbol, and we have another multiplication here, which means that we are allowed to write this one big cube root as 2 separate cube roots, which are multiplied by one another. We have the 5 in the first one and the 3 to the power of 3 in the second. Okay, so much stuff. We still have the fourth root outside here, but what can we do now with this cube root? Now we have the cube root of 2 to the power of 3 here. And if you have the same number here as your index and the same number here as your exponent, these numbers cancel each other out, so to say. The root disappears and only the 2 here is left. So instead of this thing, we can only write a 2. Then we have the multiplication here. If you don't like working with roots, by the way, you can always write a root as a power. So the rule is, if you, for example, have the bth root of x to the power of a, so this is what we have here. We have the cube root of 2 to the power of 3. So we have this structure here. Then you can always write this as, you take this base, the x, and then you get a fraction as an exponent. What we had here as our exponent will be on top here, and the index here of our root will go here on the bottom. So instead of roots, you can always write them as powers, and usually people know the rules for powers better than the rules for roots. So your choice. We have worked with roots here the entire time, but as an explanation why this here results in a 2, we can use this rule here. So our b would be the 3. Let's write this down here. The 3 for the b here and here then. A is the 3 as well. So instead of the A, we have a 3. And instead of the A, we have a 3. And then our x, in our case here, was the 2. So instead of the x, we write a 2. Here, instead of the x, we write a 2. And now we can see that this expression, what we had here, is equal to 2 to the power of 3 over 3. And 3 over 3 is just equal to 1. So we have 2 to the power of 1, which is just 2. So this is the result we see here. So feel free to use powers instead of roots. We just use this, and now we keep going here with our second cube root, but this is just the cube root of 5. We cannot do anything with this. We just have to accept the fact that it is here. Then we have this plus symbol, and here we have another cube root of 5 where we cannot do anything with this, but this is multiplied by, and here this number again is the same as this number with this rule that we just destroyed here, but this is again the case that this cancels out this, so to say, and only this base is left, only the 3 is left, so we can write down the 3 here. And I'm a fan of having the numbers first, as it is here, and then the roots. So I would like to switch these two, that I have the number first in front of my root. So I switch these two, and then we have this here right now. Okay, our rule is back here. What can we do now? We still have this big fourth root. And now, can you see that we have the cube root of 5 here and the cube root of 5 here as well? There is a plus in between. So we have 2 green things plus 3 green things, which in total is 5 of them. So we have 5 of these green things, which are the cube root of 5. Okay, we don't need this big root here. What can we do now? We still have the fourth root of. And maybe, if you don't know what to do with all of this now, what we could do is actually write this root, this cube root now, as a power, because we're like, okay, I don't know what the rules are going from here with the roots, but maybe I know some rules for the powers. So let's convert this root into a power. So we have the 5 times in front of this. And now let's apply this rule. We have our b is the 3. Our x is the 5. And what is our a? We cannot see any exponent here. Then it is always a 1. So 5 to the power of 1. Okay, with these numbers, we can write this as, this is our base, so it's the 5 to the power of, it's going to be a fraction. Our a was the 1, so the 1 goes on top. And our b was the 3 here in this case, so we have the 3 here. Okay, now we only have this 4th root here on the outside, so we still have the 4th root, but what can we do inside now? We have 5 times 5 to the power of 1 over 3. We could write this 5 here also as a power, so the exponent, we cannot see the exponent again, but it is a 5 to the power of 1. So we multiply a power of base 5 with another power of base 5. There is a rule for this, how to multiply these two powers. The rule is the following. If you have something like x to the power of a times x to the power of b, so we have the same basis, what we have here, then the result is x to the power of, and now we add these two exponents. So we have a plus b. Let's apply this here, which means we just keep our base, so the 5, and our new exponent will be 1 plus 1 over 3. So let's calculate this. 1 plus 1 over 3. We can write the 1 here as a fraction as well, so 1 over 1. And to add these two fractions now, we need the same denominators. So we would need a 3 here as well, which means we can multiply by 3. 1 times 3 is 3. We just have to do the same on top here. 1 times 3 is 3. And now we have the same denominators, so we can add these fractions. We keep the denominator, and on top we have 3 plus 1, which is equal to 4. So this is our new exponent here now. We have 4 over 3. Okay, this is our expression now. Still not perfect, but what else can we do here? We only have this 4th root left here, so we could use some rules for working with roots, or if we don't know these rules, we could just write our root as a power and use these rules then. So let's do this here. What is my b? b is the 4. My a is this exponent, which is this fraction here, and my base is my 5. So this rule says you can write it as, here, this is my base, my 5. I get a fraction as an exponent here. My a is this exponent, so this fraction in this case, so this goes here on top. And down here we have the b, so we have the 4. And now we have the 5 as a base, but here we can simplify this big fraction. So let's take this fraction and let's divide it by the 4. So we want to calculate 4 over 3 divided by 4. Let's write the 4 as a fraction, so 4 over 1. And we divide by a fraction by multiplying by its reciprocal. So we have to switch these two numbers. We have the 1 here and the 4 down here. And now we can multiply. Before we multiply, we can cancel the 4 here and here. So the only thing that is left is the 1 here and the 3 down here, which means we have 5 to the power of, and this is our new exponent. So now there is nothing else to do. This is our result if we want to leave it as a power, or we can write it as a root. Again, if we like this expression maybe more as a result. So let's use this rule here again. Our base is the 5, so we have the 5 here inside. What we have on top here is our a, so our exponent, which is the 1 here on top. This goes here. And our b is down here. This will be our index, so the 3 is here. 5 to the power of 1. We don't need this to the power of 1. But we have the cube root of 5 as a final result. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care.